right, so first we're going to introduce our distinguished panel of judges. So first, you should recognize this individual. She's a command pilot with over 4,800 hours in multiple AMC aircraft. She's your AMC commander, General Mary Ann Miller.
You all may have heard from him earlier today. Our second judge serves as the principal advisor to the Secretary and the Chief of Staff of the Air Force for research and development, tests, and modernization efforts. He is the Assistant Secretary of the Air Force for Acquisition, Technology, and Logistics, Dr. Will Roper.
All right, up next, representing the enlisted force. He's a highly experienced vehicle operator from all across the AMC enterprise. He offers seasoned enlisted perspective and serves as a principal advisor to the commander, your AMC Command Chief, Chief Master Sergeant Terrence Green.
Here to bring us an industry perspective, our fourth judge is the founder and managing partner at Techstars, the worldwide network that helps entrepreneurs succeed. He's founded several companies and has invested in hundreds of startups, including Uber. His investments have created over $100 billion in valuation. Mr. David Cohen.
And our last judge, if you want to find him this Saturday, you're going to have to go to the big house as his Wolverines battle Notre Dame. Please welcome back to the stage, Dr. Jeff DeGraff.
So this year, AMC hosted its first campaign on AFWERX's Idea Scale portal. To reach this point, AMC fielded over 64 ideas. Of those 64 ideas, 34 were nominated to AMC by your wings and directorates.
All right, of those 34 ideas, they were peer-reviewed and down-selected to 10 top ideas. Those 10 top ideas were then put across the directors at AMC to your 5 finalists that you're going to see briefed today.
Before we meet and hear from our esteemed 5 finalists, we're going to give a shout out quickly to the semifinalists who made the list.
All right, starting out at Joint Base with Wire, Master Sergeant Robert Seberg developed an idea for drones for aircraft recovery. Out of McCord Air Force Base, Staff Sergeant Joey Creeley had an idea for using GPS tracking for age equipment. Tech Sergeant Christopher Culver out of AMC headquarters had an idea for a common operating picture for first responders.
Staff Sergeant Phil McHenry from Travis Air Force Base with his idea for the paperless ATOC system. Master Sergeant Lefevre from the 317th Air Mobility Wing out of Dias with his idea for the Expeditionary Load Assist trailer. Let's all give a round of applause for these semifinalists.
All right, so let's get things started. So what are the rules today, Chris?
So the rules today, just pretty simple. So each presenter will come up, you'll have 3 minutes to present, and then the judges will have 4 minutes to ask all the tough questions, and then the judges, you'll have 1 minute to share your thoughts with the audience. And then they'll pick the winners, and then Tony and I will talk a little bit about innovation.
All right, great, so let's get things started.
All right, now it's time for us to bring our first innovator to brief the tank. Out of the 821st Contingency Response Squadron, we've got Staff Sergeant Miller out of Travis Air Force Base. He'll be briefing his idea called a 3D printed USB adapter for the tactical airfield light.
Thank you for the introduction, Major. All right, so the contingency response capability is to open airports at austere landing zones, or LZs, in places like Syria. We then support expeditionary missions, such as the retaking of Mosul, Iraq from ISIS. Night landings require pilots to aim for the center of a box of 4 lights placed on the LZ's approach end, with 1 to 4 lights marking the departure end. Think of this box like a lighthouse in an ocean of wilderness. It guides pilots away from a rocky shore and into a safe port. For decades, landing zone safety officers, or LZSOs, have drawn this box using battery-operated phantom lights. They're small, durable, capable of both visible and infrared light, and they're used throughout contingency operations. But they're vulnerable. 4 AA batteries only provide a few hours of energy. This means that LZSOs must waste their precious time managing their battery life. This is often in dangerous conditions. Also, our unit is expected to operate for 60 days at a time. We might burn through 4,000 batteries. This puts stress on our supply. Because if we run out, it could stop the mission, and we can't just go to Walmart for more. This LZ had no lights. Taxiing only on night vision goggles, the crew went off the LZ and into the mud. Digging them out shut down the supply route into Syria for 2 weeks. We must provide pilots with every possible operational advantage. This includes proper lighting. AA's threaten that capability. We address this vulnerability by designing and 3D printing a AA to USB adapter, which adds flexibility to the Phantom Light's energy source. Landing zone safety officers can insert the adapter into their existing Phantom Lights and use any USB battery. If they ever need to return to AA's, they simply remove the adapter. Here, we've combined the adapter with the light and a cell phone power bank. The cell phone power bank provides 40 hours of light per charge and is partially recharged with solar energy. By using a rechargeable battery, LZSOs can set and forget their lights, instead focusing on higher mission priorities. In wartime, this is priceless. We have tested the adapter at Fort A.P. Hill, Virginia for a unit exercise. We've also tested them at Cedar Creek, Washington at Exercise Mobility Guardian. While there are parts of the design that we'd like to improve, we are confident the adapter can execute the mission. We're at a crossroads when it comes to scaling the production. We could invest in a traditional approach and mass produce the adapter. However, our minimally viable product isn't necessarily a final product. We could also invest in an agile approach and invest in our airmen, teaching them to make and alter these adapters as their mission evolves. It's probably some sort of hybrid solution, and I'd like help in navigating this journey. Thank you to everyone that made this project possible. Are there any questions?
Thank you for briefing, Sergeant Moore. Over to the judges for 4 minutes of Q&A.
Sure, I'll jump in. Very ingenious, no surprise. You figured out something ingenious. Very MacGyver-y, I love it. I guess I have a question about, providing even more value. Have you thought about the ability for this device maybe to collect some data about what's actually happening? Because now you're in the power stream. So I totally get the utility of it. I think it's great. But I'm just wondering if you thought a little bit about how you might collect information about when the device is being used, how it's being used, where it's being used. That might be a way to add value to what you're doing.
Thank you for the question. So right now, we try to keep the adapter as simple as possible. It's just 2 wires and a USB port. However, there is physical room within the adapter itself to add some sort of data collection thing. And I would push them to give this to the airmen and see what they come up with category.
So great job on making your value proposition. You clearly articulated the problem, the solution, you had a compelling need, you quantified numbers and made it real. So excellent job on that. Question I have, what's the number that the Air Force needs to be viable? Like how many of the adapters would we need per year in order to change the game and pull ourselves off of AA's?
So right now I only have a back of the envelope estimate as far as special operations forces that use these and the contingency response forces. But I would estimate probably about 2,000 adapters could shift the paradigm.
I also want to congratulate you. I like the proof of concept, and you've done a lot of thinking through that, the difficult kind of issues. Did you look at other industries that might have already solved this problem? I think of construction, I think of in medical. And because the real value added here seems to be not the battery or the light, it seems to be the use in the Air Force of that. So did you look at all, did you do some deep diving into these other industries to see what exists, and maybe you could modify something that's sort of jumping the production cycle to where it's already usable?
Thank you. We haven't, I can never say that I've done an exhaustive search, it's such a big world, but we did do sort of a solution landscape to see what's already available. The one alternative that we found were power flares for helicopter landing zones, and we actually tested those first with a C-17 crew out of Travis, and that solution wasn't good enough, and I was very upset because I was hoping to just use a commercial off-the-shelf solution, so instead we created this adapter.
Hey, Sergeant Perry, this is really great. So, question for you. So this is for contingency operations, right? And they're in kits. So how often do you guys actually use this? Like, for how long would you use it when you go out to set up?
So within the CRS, we'll use a typical exercise is how we're using these most often, which is about 2 weeks. And then if we're on some sort of transcom tasking, our bill is for 2 months of operations.
So when you're out, you actually need more than those AA's can actually carry you through.
Correct. And if it's particularly cold, the life on the AA's go way down, and you have to just throw them out when you're done.
Hey, great job with this. Question about the weather, moisture in these connections. Did you guys look at that at all?
Yes. So the test that we got at Cedar Creek, Washington, it rained while we were out there. The adapter itself is fine. The commercial power bank that we're using right now is weather resistant. The issue that we're having is surface rust on the USB cord itself. So we're looking into ways of actually tightening up the weather seal on that.
Thank you, judges. And if you don't mind, just sharing any remaining thoughts to the audience about Sergeant Miller's idea.
From my point of view, this is exactly the kind of innovation that we want to unleash. You're faced with a problem, you brought a practical solution. I applaud you for looking for commercial solutions first. You know, that is something we need to get a lot better at. I applaud you for testing them. And then looking to create a solution where you identify that you could go mass produce, you could go with a tailored boutique solution, we could try to make them ourselves. And your thought that we probably need to do a little bit of both is most likely the right solution. So great job to you and the team.
Thank you.
All right, thank you. All right, so next up out of Ramstein Air Force Base, Germany, with the C-17 Wedge, we have Technical Sergeant Brett Kaiser. Please welcome to the stage.
Good afternoon. I'm Tech Sergeant Brett Kaiser, a proud port dog from the 8th Expeditionary Air Mobility Squadron located at Al Udeid Air Base, Qatar. Today, I'm going to highlight how the C-17 fleet is being damaged during cargo loading operations and our proposed idea to mitigate and hopefully eliminate this from occurring in the future so that AMC can deliver rapid globe mobility at the speed of war. So the problem is actually really simple. During cargo loading operation, 4630 cargo pallets strike the logistics rail in the C-17. And so from some GO81 data that we got from Charleston, each rail incident can cost up from $1,500 to $9,000. And since January of 2018, there's actually been 63 rail incidents. So that's a potential maintenance cost of up to $567,000 at just one operating location. Here's some pictures of some aircraft damage. We have bent actuators, bent rails, and even some broken rails with huge chunks taken out of it. And we've been operating this way for over 25 years, until now. Introducing the K-Wedge, a 3-piece C-17 loading aid that's designed to protect the leading edge of the logistic rail system and also reinforce the outerboard rails or pallet spinning. It's made from 3/16 inch steel plates that's fabricated to its current design, and it takes 5 hours to make and only costs $500. Here's what the K-Wedge looks like when it's fully installed on an aircraft. And a quick video on the installation. Right now it's stored on the 60K tonner loader in the video, and it's rapidly installed in under 1 minute using existing tie-down rings on the aircraft and a cargo strap to provide necessary tension during cargo loading operations. So for those of you who are familiar with the C-17, you might be asking yourselves, well, we have ramp tows for a reason with guide rails. Why is this issue still occurring? There's two reasons. One, you have to take the ramp tows completely off if pallets or pallet trains are over 8,400 pounds. So that leaves the logistic rail completely exposed. And even when the ramp tows are installed, there's about a 3-foot gap between the logistic rail and the ramp guide. So in the middle is omnidirectional rollers, which still allows the pallets to shift and strike the rail system. So our final request is that we get AMC's approval to test, fine-tune, and adopt the K-Wedge. We'd like to designate that the K-Wedge is stored on the C-17 and ensure that every C-17 has one. So no matter what austere location the C-17 is operating at, it's going to be protected. And we all know that the C-17 is going to be delivering rapid global mobility for decades to come. So let's fix this problem to protect our airmen, aircraft components, and our unique capabilities. Thank you.
I think we're still on, right? So you say that we actually keep damaging the rails. We've been doing that over the years,
Yes, sir.
and we've never really tried to fix this problem.
No, sir.
Well, I think it's a great, this is incredible that you identified that, especially in our resource-constrained environment, to say, holy crap, we need to fix this problem, to come up with an idea like this. I think that's really good.
Sir, thank you.
When I first see something like this, my reaction is always, it's a very specific application. And I think that that's often going to be the case in this context. When you think about any business or any innovation, you have to think about return on investment. And again, I always go back to data. Looking at this, I see data. I see hard collisions on this device. You can't see it in the audience. There's 2 or 3. You see many other collisions. I wonder if that data could be used to create an ROI justification beyond a guess.
Yeah, we would like to, I think that's the reason why we request, live operations and testing this device, so that way we can gather more data and even, fine tune and make the prototype even better. And then once we do that, then we can implement this on every C-17.
It's heavy also.
So you did a great job of capturing what the cost impact and savings could be from doing this, but do you have a sense when you break a rail, bend a rail, what's the time it takes to repair it so you're back up and fully mission capable?
It can take anywhere from 1 to 8 hours to complete. So whenever there's a no-fail mission, and we're at an Al-Udeid Air Base, Qatar, with everything going on in the world, bending and breaking a rail, it has huge consequences that has secondary and tertiary effects. That those rippling effects are long-lasting, we feel that. So for instance, we've seen this multiple times out there where we have some no-fail missions and this happens. And so that's exactly what started this whole idea, was saying like, hey, we have to get this cargo out, lives depend on it.
So I thought that would be your answer. Time is, I think, your more compelling selling case, right? You pitched your problem in terms of the cost savings that you could get, but it's really the time savings that are your most valuable commodity, and that's what actually drove you to this solution. So I'm glad that you did that in audio. I think it would have been a great addition to your pitch. Yes, sir.
I thought you did a really fine job in making the case for this, and I love the fact that you field tested it. But this is what we classically would call an aftermarket product. It's like camping, or whatever. You get your new iPhone and all the crap you have to buy with it. And the classic 2 questions about an aftermarket product are: what other materials could we make this out of? And the second one would be: what other uses can we have for it? This whole idea.
Sir. So basically we wanted to make it out of thin steel because the aluminum rails on the C-17 are already being damaged very easily. So we wanted to just create, a prototype that can withstand, 10, 20,000-pound pallet trains hitting this thing and protecting the rails. So, but we can easily be made out of different material that's lighter, especially if it's going to be stored on the C-17.
Okay, and then what other uses could we have? You've got a great aftermarket idea here. This applies to this, and not the exact product, but what else is this idea can be applied to? What other kind of problems you have that this kind of thing can solve?
At the time, I can't think of any other solutions or problems that we need to fix using the K-Wedge. Like I said, it's an aftermarket product that fixes a very specific product or a very specific problem that's been affecting the C-17 fleet for years.
I may be able to bust some bureaucracy with it in the Pentagon. So I think we've got an application. There's a lot of things come off the rails there figuratively. So maybe just to keep them back on.
All right, judges, any closing comments? All right, well, thank you very much, Sergeant Kaiser.
All right, next up in the tank, out of the 521st Air Mobility Operations Wing at Ramstein Air Base, Germany. We just did that one. Fail. Next slide. Next briefer to enter the tank comes out of the 19th Civil Engineering Squadron out of Little Rock Air Force Base. Please welcome Master Sergeant Jacob Hamilton, who will brief his idea 3D printing initiative, pushing EOD left of the boom. Thanks.
Good afternoon, judges. As we know, I'm Master Sergeant Jake Hamilton from the 19th Civil Engineering Squadron, Explosive Ordnance Disposal Flight out of 19th Airlift Wing, Little Rock Air Force Base, Arkansas. At the 19th, our motto is Ready Warriors. And as EOD operators, this is a concept that we take very seriously because we live by it every day. There is no substitute for preparedness. However, in today's rapidly evolving battle space, it's hard to stay on top of every threat that you can encounter. My proposal is for an effective 3D scanning and printing program that will revolutionize the way that EOD trains. We have the ability to gather, exploit intel, and train on the latest items in record time, occurring in hours and days rather than months and years. And in doing so successfully, we will keep our operators on the forefront of preparedness, innovating at the speed of war, and ultimately saving more lives. As EOD is a joint community, it will also benefit our four sister services, increasing their proficiency and enhancing their survivability as well. This program could also be shared as a joint service venture with our allied warfighting partners to make sure that they're up to date as well. As we all know, training is a cornerstone of any effective program. Unfortunately, training effectiveness is often hampered by availability of funds and other associated resources. When we encounter an unknown item on the battlefield, the time it takes to exploit that item and put it in the hands of the warfighters so they can effectively train against it is a major hurdle for us. Additionally, we have to procure those items, often through a commercial vendor, and that comes at a high cost. This makes those items unsuitable for training because it's often destructive. With this proposal, we will be able to build a training ordnance library by 3D scanning ordnance that we find anywhere in the world, from our backyard to the battlefield. Whether that's a World War I era grenade that's been in Grandpa's closet, an experimental round that's found on an old test range, or the latest creation that was deployed against Allied forces just last week, we're going to be able to print this and put it in our own hands. Without question, this program will save lives. By outfitting 140 of our X1 UTCs with a 3D scanner and printer and setting up an effective support network that will either host or disseminate these files, we're talking about revolutionizing the turnaround that it takes to provide the most current and relevant training aids to the EOD career field. I'll say it again. We're talking about putting the latest threats in the hands of our operators in a matter of hours or days rather than months or years. It only makes sense that we conquer this front as our enemies are using this against us. Conflicts in Iraq and Syria have seen the rise of sophisticated and reliable 3D printed munitions that have a high degree of accuracy and lethality. It's time for us to step up and meet this threat head on. I'm asking for a total of $4.5 million to get this idea off the ground. $2.4 million would be used to deploy 2 people to test the equipment and find the specs that we need to outfit the career field most effectively, as well as determine the best method for hosting these files and getting them out to the operators. Working on a budget of only $15,000 per UTC, $2.1 million would be needed to outfit the force with the required equipment. With an estimated savings of $930,000 to $1.24 million annually, we stand to cover our costs in 3 to 5 years, or in one single day if we consider live currency, as we all do. Thank you.
Judges, over to you for questions.
Yeah, I have a question. Given the urgency of this, right, that there's always a trade-off between building and buying, right? And when you talk about 3D printing, I mean, when you get to mass, it's going to be quite a bit of expense. Given that the amount of time you want to take, have you thought at all about outsourcing this? Meaning going to somebody who already has the ability. Let's think about sort of like the Amazon models. Like somebody who has the ability to do this, proofing the concept with them, learning what really works from people who do this already for the automobile industry and other industries, and then maybe 9 months down the road, 10 months down the road, investing in this now that you've sort of worked out all the bugs with somebody else's money and time. Did you explore at all other people who kind of are in this business?
No, sir, not exactly. Some of the things that we look at is a lot of the training aids that we buy these days commercially are already 3D printed. So these programs kind of exist out there, and we're stuck paying for them when we can turn around and print the same thing for literally pennies on the dollar. A $150 item will cost you 60 cents to print. So the proof of concept is out there, and it is being used. It's just we're not taking advantage of it to save ourselves money and put us back in the fight as quick as possible.
Thank you.
Just to follow on that idea, there are startups and there are companies in the world that do outsourced printing of models. And so, as we heard earlier, I think partnering with a startup could be really interesting here. Perhaps the type of need you have and the budget you would have for it would be compelling to get them to create an instance that keeps the information private, which I'm guessing is a concern. So I was curious too about maybe working with services that do this, but bringing them in for the distribution that you have and that you want to use that service for. Are there startups that you've seen in this space? I could probably refer a few that I've seen.
I hadn't really looked into that. I can't give you a straight answer one way or another, but it is definitely a route we could explore.
You know, with your slip from 2.4 up to 4.5 million, you've already learned some good tricks from the defense companies here, so you're ready to go. 2.4, 5.6 million. I think the one thing, so, you know, 3D printing is something we're really passionate about in the Air Force. We're printing parts, we're printing, you know, things that are in short supply, so there's a really good business case for it when it's an obsolescing item that we can't get a good price on from the commercial industry. The thing that I would ask, and it's probably going to have to be part of your market research, is can we move into printing without having to take on the overhead of the machines themselves? 3D printers change over really fast. It's a fast-moving market. So where we can abstract ourselves from the upfront overhead of buying machines and then printing and then having them become obsolete puts us on a better side of the price curve. Have you thought about it? And if not, is that something you think you could do quickly?
It's a good question. It's hard to say at the rate everything's progressing. That's why I tried to keep it at a relatively low number, $15,000 added to the price of that UTC is maybe 5% of the cost of that UTC. So in the grand scheme of things, as we talked about expanding that library and being able to use it for additional functions, there's already other 3D printing initiatives within EOD. We can print tools and robot parts, so it will help absorb some of that cost, and replacing these things on a somewhat regular basis shouldn't be as big of a financial impact because it'll definitely grow and be a multifaceted tool in other aspects.
So question, I know we're focusing on the actual manufacturing, you know, in terms of printing these models, but the other piece of that I keyed in on as EOD, when you're out there in the field and you find a new device, you know, that our adversaries have placed out there. There's that piece of 3D scanning it. Where does that piece come in terms of the funding and training? Because that piece would have to be done in the field to get that file back. Am I understanding correctly of what the plan is?
Yes, Chief, that's correct. That's why we would be looking at 3D handheld scanners for our teams that are operating in the field. That way, they don't necessarily have to bring something back to their installation or have a big piece of equipment. They can scan this stuff on the ground and they decide it's not safe to transport, then who cares if it gets blown up? So having that ability anywhere and everywhere that an operator can go and carry in a pack is just a phenomenal concept. So that's why we're pursuing it.
All right, well, thank you very much, Master Sergeant Hamilton. All right, next up to the tank, out of Scott Air Force Base, A4, we have Tech Sergeant Omar Abu. Please welcome him to the stage.
Judges, thank you for allowing me the privilege to stand before you today. I am Technical Sergeant Sharif Abouomar. I'm Air Mobility Command's Non-Destructive Inspection Functional Manager. And for my Phoenix Spark initiative, I want to introduce you to non-destructive inspection of the future. For those of you that don't know what non-destructive inspection, or NDI, is, it is the study of analyzing parts and materials for defects without destroying their structure or use. We are a core component of Air Force fabrication and a key element to air power sustainment. What you are seeing is an unchanged process requiring parts to be removed from the aircraft, stripped of paint, inspected, then repainted before being installed back into the aircraft. These steps drive a 5-step process, 3 of which expose our airmen to the dangers of hexavalent chromium and other hazardous materials. Steps 2 through 4 can take up to an estimated 28 hours before the part is ready to be installed in the aircraft. This process greatly affects our aircraft availability and puts added strain on our most precious resource, our airmen. On the right is our future, and a new path forward, all made possible with a technology that has saved countless lives. That technology is computed tomography, or CT. This is a game-changing technology in the field of non-destructive inspection and offers us the same capabilities as the 3 legacy stationary systems on the left, and 6 additional capabilities such as 3-dimensional high-resolution scanning, digital twin replication, man-machine teaming, automation, CAD rework, subtractive additive manufacturing support, and so much more. On the left is a weld certification coupon image, captured using the legacy X-ray systems that we employ. On the right is the same weld certification coupon scanned using CT, demonstrating the immense differences in capability between the legacy technology and the level of analysis that CT can perform. Those legacy systems cost Air Mobility Command $3.27 million annually in hazardous waste, equipment replacement costs, and man hours. With CT, we can slash that by over $2 million and offer a return on investment within 5 years' time. Furthermore, 7 of the 9 Phoenix Spark initiatives from this year and last year utilized or leveraged fabrication capabilities to produce their prototypes, demonstrating how fabrication leads innovation. CT doesn't just benefit fabrication, but the entire community committed to innovation. This initiative has been aligned to meet, This initiative has been aligned to meet 5 of the 6 Air Mobility Command priorities and all of the senior leader priorities for Phoenix Spark. To bring NDI of the future into reality, I request $1.1 million to outfit 1 AMC maintenance group with this technology to showcase what this technology can do for us. Thank you for allowing me the privilege to present this, and I look forward to your questions.
It's compelling, it's future-oriented, and I think is applicable to a much broader set of things in the Air Force. You didn't just pitch a technology, you pitched a different universe for us that's focused more on digitizing the way we do inspection, and I see the huge value in it. The only thing that I disliked about your pitch is I think you should have asked for more and go bigger.
Well, sir, I'm actually glad that you mentioned that, because originally we asked for $10 million to outfit all of AMC with a return on investment of 5 years' time, and then we did the cost across the MatchCom to quantify exactly what it was that we had and make sure that everything matched up accordingly.
And what was the response to the go big? Was it go home or go small and go to the stage?
Low risk for right now until we start to build up and then we get the pilot going.
Tomography is classically sort of a mid-office bridge system. And these kind of systems are often used to solve a problem, and you're solving the problem of repair. But actually, most of these types of systems are actually more valuable in the predictive mode, meaning, you know, you're not only looking at what part has failed, but you're getting data on what parts are likely to fail, right? You're gathering data on going forward. Have you given any thought to the opposite end of this, rather than trying to make something not happen, to what could be done with the data to actually create some unique capability that the Air Force doesn't have right now?
Yes, sir. So with CT and the capabilities of failure analysis, reverse engineering, and prototyping, we can actually create an element of quality control engineering that we currently don't have in the field right now. So even though we can sit there and scan components, and we develop that data can be attributed to so many other facets of maintenance, not just for my career field, and to eliminate old practices.
Okay, so I want to interrupt you and say, so then it's not really a maintenance technology, you're really developing a solution here. You're developing a solution business, which is very valuable, but it's taking that data and it's repurposing that data in a number of ways that give us some competitive advantage against the enemy.
Yes, sir.
More of a comment than a question. I love, I don't know where the branding came from, but non-destructive inspection of the future is one of the coolest things I've ever heard. And I'm wondering if I can use this at home with my kids or...
He's patented already.
Thank you, Sergeant Abouomar. Appreciate it. Next up, the final briefing today comes from the 6th Maintenance Squadron out of MacDill Air Force Base in Florida. Please welcome Senior Airman Cuttito. Hello, everybody. I'm here to present the idea of using thermal imaging technology. So the big problem we have in the Air Force right now, as far as the aircraft maintenance side of things, is what you see up here, removing panels and floorboards, troubleshoot stuff behind them. Then we have the trial and error side of it, you know, potentially not getting the correct part changed, misdiagnosing, and also the cost of all that goes along with it. Using thermal imaging technology, maintainers can see the problems without really breaking into the system. So that would pretty much increase productivity and the availability of aircraft. We're going to avoid that costly misdiagnosis, and we're also going to keep ourselves out of harm's way. A lot of times with TOs, technical orders that we use, they'll actually tell us to feel around for hot components, whereas now we can just, from a distance, look at these things and determine, you know, hey, I've got a hot spot right here, here's a problem. So what is thermal imaging? It's a technology that's used to translate heat into something that we can see with our eyes. It uses sophisticated processes to capture images and put it on a screen. So some of you might be wondering, well, I've heard of this technology before, and what's really the differences between some of the devices that we can use? My pitch is for thermal imaging versus some of the infrared thermometers that you might see. Thermometers will really pinpoint a very small area, whereas with thermal imaging, we can really look at a very larger scale, and we can also see the kind of the big picture as to what we're looking at. With using thermal imaging, we can also have data-driven decisions. We can look at a part, we could even look at its lifespan and say, hey, this part might be failing soon, just based off of some of the temperature readings that we get off of it. But also, it can allow some of our career field specialists to really make decisions based off of, hey, here's a temperature versus a good component versus a bad component.
Here's some of the uses in aircraft maintenance. That's the field that I'm from. So I'm a hydraulic specialist, and there's a ton of solutions that we can use it for within the hydraulics field. Bypassing hydraulic components, leaks, some of the electrical side of things, shorts and amperage draw, bleed air ducts for aircraft pressurization, engines to use to see some of the heat coming off of them, whether we have a good component or a bad component. But the great part is that this isn't just the aircraft maintenance solution. We can also use this on the automotive side as well. Engine misfires, cabin and weather stripping leaks, brake malfunctions, air conditioning, and also electrical shorts. So you can see in the picture here that's up on the screen, on the two bottom pictures, is an exhaust manifold off of a car. With the picture on the left, you can see all the cylinders are firing correctly, whereas on the picture on the right, you can see the cylinder that is not firing, it's not producing heat. We wouldn't be able to see that with our naked eye. Civil engineering for some of the guys that are CE in the house. Roofing inspections, AC, water leaks, electrical stuff. Really the possibilities are endless. So you might be asking, what are some of the costs to get this into the Air Force? We're looking at a class cost of $2,000 per person. I would like to throw out that Staff Sergeant Moore, who is my partner in this, has created a complete training for this. The cameras really vary on the prices of how in-depth you want to get. You can go from $1,000 all the way to $50,000 depending on your specific needs. One of the other things we were asking for is to add the stuff to our technical orders. There's nothing here within the Air Force right now that says, hey, use technology like this to solve problems. And of course, one of the biggest challenges we face is the culture of our Air Force in being open-minded to use new ideas. Questions?
So one question I had, I think it makes a lot of sense to use this as a diagnostic tool. Do you worry that there may be things that you really do need to remove panels and get the eyes on inspection, and that having this as a quick triage might tend to create a propensity to remove panels less often than we should, or things of that nature? I'm trying to make sure that we can keep this where it's not a cure-all, but it's used where it's useful. So what were your thoughts on that?
Sure. So I'm a big supporter of doing things. You have to take everything in stride. So there are going to be times where we're going to need to remove panels. We're going to need to do that extra follow-on maintenance. Kind of the old way. That's always been we've done it for 60 years that way. So it's always going to have its benefits. But the way I see it, just because we work on 60-year-old pieces of equipment doesn't mean we need 60-year-old maintenance practices. So I feel like using technology like this could very well save time, money, effort, manpower, and the bottom line, mission effectiveness.
You took a pretty wide angle here, that it sort of covers everything. It slices, it dices, it makes your hair shine, the whole thing. And I like that. I like that you're thinking big, so let's encourage that. But if you focus this seems to me to be something more in line of something you use for critical events. Think of it like a fire truck. There's a lot of things you could look at, but a fire truck you don't use all the time. You use it, 10% of the time? But when you use it, you got to have it. Have you thought at all about focusing this on maybe a few types of technology that are sort of critical, that you do this in real time? And if you have, what would those technologies be? What would be the one specific subsection that you would really think this would really, sorry for the pun, really shine?
That's a great question. It would definitely be aircraft maintenance. So as a maintainer, I can definitely see the value with this. So can most of the other maintainers I talk to. When I tell them about this, they go, wow, we didn't even think about this. I don't have to pull a panel off, or I don't have to do this follow-on maintenance. I can essentially point the camera at something and almost determine whether it's good or bad, or with a predictive maintenance side of it, I can say, hey, we have 50% of the lifespan of this part is there. So I would definitely say aircraft maintenance.
Thank you.
Yes, sir.
Question about the cameras and the range of cost. It went from, I think, 1,000 to 50,000.
Sure, it is a big range.
And I was curious about where good enough is on that spectrum, or what that range represents in terms of
So
quality.
I think that the cost is going to, the most effective camera that's going to kind of meet all needs is going to run right around $8,500. And our plan is to get roughly 5 of those per aircraft maintenance unit. And of course, you know, it's such a broad spectrum. I'm mainly just talking on the aircraft maintenance side. I couldn't tell you, you know, how many CE would need or how many, you know, the automotive side would need. But as far as aircraft maintenance, we're looking at 5 that would be spread across the maintenance group.
You had on there that, you know, you had training, and you have $2,000 to train each person using that. Is there, what kind of length of training, what does that entail? Assuming it's just a camera that it brings up a picture.
Sure. So the training I received costed $2,000 per person to be sent to. It was like an aftermarket training to be level 1 thermography certified. But Sergeant Morin, who also went to the training with me, he pretty much wrote a whole section of training for the Air Force, so we could essentially slash the cost of training by using slides that we already have.
All right, thank you very much, Senior Airman Cuttito. All right, so let's give one final round of applause for all our 5 finalists. So next, judges, you're going to deliberate to come up with 3 runner-ups, a second place, and then a first place award. The first place and the runner-up, both those ideas are going to be submitted to the Air Force level Spark Tank competition for consideration for AFA early next year. So with that, judges, please start your deliberations. And if you could turn off the judge mics, please. All right, so first, let's point over to the trophies. So these trophies were designed and printed at Travis Air Force Base and McGuire Air Force Base at their Spark Cell labs. So if we could please recognize Airman Evan Van Oaknell. Is he here? Please stand up. Please stand up. And then Technical Sergeant Zach George for designing and printing this year's trophies. And next up to thank, we have a team out of the ELO, out of headquarters. We have 3 individuals that put this entire competition together. They put together the Idea Scale campaign. They wrangled all the cats and down-selected to the 5 finalists that you saw today. So please, if they could stand up, Mr. Shane Hirschman, Bill Hammerly, and then Jen Mendoza. Please give them a round of applause. Put on this competition. So thank you very much, everybody. So as the judges are deliberating, let's talk a little bit about how you can get after innovation at your base. And so there's many pathways out there. One pathway that Travis Air Force Base, Chris and his team have leveraged to some degree, upwards of $5 million of other people's money, is the AFIRP's AFRL SIBR open topic. So Chris, could you talk a little bit about what you've done using this pathway to bring innovation to Travis?
First, we've got to thank Tony, because I'm his replacement's replacement. So he stood the Spark Cell up in 2016 out of the operations group, and it's kind of grown and blossomed into what it is today with over 45 Spark Cells out there in the ecosystem. So the program that Tony's talking about, the Small Business Innovation Research Program, it's not my money, it's not my boss's money, it's not my wing commander's money. It comes from the Small Business Administration, and it's a pot of money that they give to startups to basically empower them. So these products are nothing without the customer, right? So that's what we do in our Spark Cell. We have access to the airmen like you who have compelling problem statements. When you show up to work and something is, not efficient, or you'd like for it to have a better kind of product than what you're currently working on, you can find a best-in-class startup out there through Tony and through AFWorks that already has a commercial off-the-shelf solution that's viable. and then match it up to a problem statement you have. And for us, you know, we talked about this earlier. We have several initiatives. You know, we're doing augmented reality, virtual reality projects. We're even getting into AI and machine learning to get after our data sets. So this is something that us airmen really didn't have access to before. We don't have time to get into virtual reality or artificial intelligence. We have day jobs. So this is a great avenue that we have up at AFWorks.
So the common concern when we talk about the SIVR, the Small Business Innovation Research Open Topic, is what's this going to cost me? Right? What's the tax on me as an organization? So the beautiful thing, how it's been designed by AFWorks in partnership with AFRL, is it's centralized contract execution and centralized funding with a decentralized project management of the various projects going on. So right now within the pipeline, there's over 700 companies that you, across the Air Force, can access. And you're accessing money from another pot that's not yours. All right, so with that, judges, have you come up with your final decision? Okay. And all right, judges, would you please come to the center of the stage? All right, so as we announce your name, could you please come up and accept your trophy? All right, so 3rd through 5th place. First, Staff Sergeant Miller, Master Sergeant Hamilton, and Senior Airman Cuttito. Please give a round of applause. All right, thank you very much, and congratulations to the 3rd and 5th place. All right, so now for a runner-up, 2nd place, with the K-Wedge, Technical Sergeant Kaiser. All right, thank you very much, Sergeant Kaiser. So 1st place out of Scott Air Force Base and AMC headquarters, we have Technical Sergeant Abouomar. ceremony, so thank you very much. One final round of applause for our esteemed judges and our panel.